Super excited to be here today. Hey everyone from all over the world. Thank you all for coming to my talk. So yeah, as Mackenzie mentioned, I'm from Belfast, Northern Ireland in the UK. And yeah, I joined WWCode a few weeks ago as a 2020 Leadership Fellow, and I lead the data science and blockchain tracks with Naomi. And yeah, I'm an AI engineer at Kainos, and you can find me at my Twitter handle there below my photo at Sapphire Duffy. And if you have any further questions, please after my talk, just please reach out. So yeah, as you can probably guess from my talk title, I'll be talking about what to do after you have a machine learning model. But I didn't want to start there. I wanted to start from the very beginning of any AI or machine learning project, because it's crucial to have a bit of background before we dive straight into this topic. So first, it's important to acknowledge that there is a knowledge gap in the workplace. And following on from that there, I'm going to talk about a typical machine learning project lifecycle, and then automation and continuous delivery, and how important it is to keep monitoring your model. And then lastly, I'm going to talk about an AWS cloud service called SageMaker that allows you to build and deploy your machine learning models. So I'll give you a little bit of a background of the company that I work for. So Kainos is a Belfast-grown company that has 13 offices across the globe, and we have over 1,700 employees. And Kainos provides digital technology that allows organizations to work better, faster, and smarter. And we work with the government and finance and health and commercial, and you can probably recognize a few of the big names there. And in 2018, we won 2 UK IT industry awards, and one of them was for AI and machine learning project of the year. And then secondly, we got awarded for the best use of cloud services. So I'll give you a little bit of background of the team that I work for in Kainos. So the AI practice in Kainos was born a few years ago, and it's been formed to begin a capability in delivering production services to solve business problems for both the commercial and public customers. And the roles of the AI practice is to help our customers see the value of AI in greater clarity. And this means just working with as many customers as possible to prove the value of AI in production setting. And our team of data scientists and AI engineers work collaboratively together and understand how to support the full project lifecycle from the initial ideation stage and problem solving right through to the implementation of the working solution. So so the practice provides leading AI services on fraud, risk, and automation. And as I mentioned in the previous slide, one of our successes back in 2018 was with our DVSA project to create anti-risk fraud and rating service for MOT garages using machine learning. So yeah, when you get your first model with great hyperparameters and a good model score, it's a great feeling, and this dog here agrees too. And once you have built your model, this is only the beginning, and you have to productionize it, and this includes deploying your model and monitoring it. But before we skip to what you do after you've built your machine learning model, I want to take us back to the very beginning of the machine learning project lifecycle and identify potential problems that could occur. So also before we go any further, it's important to note that there is a huge gap of knowledge out there in the industry about what the next step is after you have your first machine learning model. And in reality, to be honest, not that many companies know how to get a model into production. And productionizing machine learning model is a cultural and an organizational challenge that companies don't usually openly talk about. And this could be because maybe it's too complicated to discuss, or maybe how they do it is a trade secret, or it could be maybe too embarrassing to say how they did it because they probably might have done it in a bad way. And Intel's CEO states that every company should look into having a machine learning strategy, or they can risk being left behind. And there is a lot of pressure out there for companies to have a machine learning strategy. And you can see from this article here that only 87% of data science projects don't make it into production. Could this maybe be because many companies feel like they have to jump onto the bandwagon and join the race? Many of them maybe don't take the time to strategically think out the problem that they are trying to solve. And to put it down to it, there is a huge difference between building a model and getting it ready for production. So yeah, there could be many reasons for a gap of knowledge, like I said in the previous slide. But one of the main reasons I came across while researching was that there is a fence between data scientists and software developers. They should all be working together to combine and deploy into production, but in many cases that's not what happens. And having them separate can lead to challenges in bringing the machine learning model into production. And there are gaps in understanding the processes. The pipeline is a lot different compared to the traditional software development cycle, and it's a huge learning curve for all the people involved in the project. Yeah, so again, before we go any further, I want to acknowledge the typical project lifecycle. And there are so many different methodologies out there, but typically there is 5 main stages in the project lifecycle. The first one would be the objective and the definition of the problem that we are trying to solve. And then secondly would be data collecting and cleaning. Third, training and testing. Fourth, deploying the model. And lastly, monitoring the model. Yeah, so before you start collecting the data and cleaning it, the first thing that you should do is try and define the problem that you're trying to solve. Figure out what goals you're trying to achieve and set them. And there are primarily 2 main tasks involved at this stage. The first one would be to define the objective. So like if you're working with a customer or other stakeholders, it's crucial to make sure that your customer knows the problem that you're trying to solve too. And ask yourself and your team, is machine learning right for this project? Because the customer or the business might just trying to add machine learning to the project without really thinking it through. And this can end up being a waste of time and a waste of money. So work with them to try and understand and identify the business problems together, and with your team as well, and gather questions to define the business goal and the data science techniques can target. And then secondly would be to identify the data sources. So find relevant data that can help answer the questions that define the objectives of the project. So secondly, once you have the objective and once the objective is defined and you have identified the data source, it's now time to collect the data and clean it. So first would be to ingest the data into the environment. So set up the process to move the data from the source location to the target location. For example, you may be collecting data from a hospital and you need to make sure that this is transferred over securely into the chosen environment. Depending on the type of data, it could hold private information about the patients. So secondly would be exploring and cleaning the data. So you will need to perform things at this stage, such as the missing fields completion, removing the duplicates, removing garbage, and then feature engineering, which this stage involves transforming the values of the data set into numeric values so the machine learning algorithms can use them. And then before you train as well, your models as well, it's important to spend time exploring the data sets and spend some time understanding it as well. And if the data comes with the data dictionary, then happy days, that's super helpful. But often real-world data sets may not even have a data dictionary, and it could have missing values and it could be noisy. So it's important to check that at the beginning that the data quality can answer the question and solve the problem. And during this stage, you can perform a data analysis and use summarization and visualization to audit the quality of the data. And this step can help provide information that you need to process the data before you start modeling. It's important to note as well, this phase is super time consuming, and a lot of time is spent at this stage. And lastly, it's important to set up a data pipeline at this stage. So the data pipeline will set up a process and score, renew, or regularly refresh the data. And you will create a solution architect of the pipeline in parallel to the next stage of the project. And this usually depends entirely on the business needs of the existing system and where this will then be integrated into. And a pipeline could usually be real time or streaming, a batch, or a hybrid. So yeah, after you collect and clean your data and plan out your pipeline, it's now time for machine learning to come into play. So the data will be divided into training, validation, and testing sets, which will be used to train the model that will be able to answer the question that we have. So this stage requires all of your knowledge and findings that you have discovered so far, which is your understanding of the problem and the data. And at this stage, there's usually three key areas, which is the feature engineering, the model training, and lastly, you should carry out an evaluation and see if it's suitable for production. So for feature engineering, in this stage, you create data features from data to facilitate the model. And then for model training, there are many different algorithms out there to choose from. And there are three types of algorithms, such as supervised, unsupervised, and reinforcement learning. And from this, there's algorithms like linear regression, decision trees, and I can keep going on about how many there is. But yeah, it kind of just depends on the type of question that you have. And there's a really good article that I read in Hacker Noon, and it's called "Choosing the Right Machine," which I'll link at the end of my slides. And I'll also send out these slides afterwards as well. So yeah, the process for model training includes splitting the input data randomly for modeling into training data set and the test data set. And you can build the models by using the training data set. Then you will go on to evaluating the test data set and use a series of competing machine learning algorithms with various associated tuning parameters that is geared towards answering the question of the current data set. So now we have covered up to the point of modeling, it's now time to finally talk about what to do after you have your machine learning model. And at this stage, there will hopefully be a good model. You can now move to the deployment stage of the production environment. Ooh. So yeah, after you invested time in making a good machine learning model that performs well, it's now time to expose it to the world. And it's important to note that the production environment isn't like the laboratory. And model deployment is the most difficult part of any machine learning pipeline. It is the process of integrating the machine learning model into the existing production environment, so that we can use it to make business decisions on live or featured data. And the later stages of the machine learning pipeline is definitely the most challenging. And there are many different ways to deploy a model, and you can operationalize it from other applications to consume. And again, this usually, as I keep saying, it depends on the business requirements and the use cases or the problem that you're trying to solve. Like as I mentioned in the previous slide, it could be real time or batch. So now we'll go to, yes, deploying the model. So if you're working on this project yourself, you can think about it like this way. You're bringing your model to the supermarket shelves, and there are many different ways to model. It depends on the use case. So, and this includes the type of format as well. So once the model is generated, it needs to be saved and exported so it can be used for scoring and prediction. And the most common options would be, first to have there is the model object. So it can be saved, calling a prediction function of the model object only when scoring of the new data is required. And this works well in rapid development, but not for production. And then we have pickle. So this is a really popular method. So this serializes a model to bitstream so it can be stored and accessed later, and support it in Python and then export it in R. And then we have JSON and YAML. So this is the model as a JSON object in case of Spark ML, or as a YAML for object for Keras. And this also provides additional metadata about model parameters and training configuration, along with the compatibility for deep learning models. And then we have PMML, and PMML stands for Predictive Model Markup Language. That is a standardized method for converting models into a format which is compatible across multiple different languages. And then Pojo and Mojo, which stands for Plain Old Java Object and Maven Plain Old Java Object. And this provides the standardized way of embedding into a Java-based environment. And yeah, there's like a lot of different ways you can deploy a model as well. So you can use a machine learning model as a package. And an example with this would be Spacey, which is a natural language processing library. And you can also deploy this model. So you can save the progress of the machine learning model as an object. And in Python, this is known as the pickle object, like I mentioned. And after you save your progress and load it back into the machine learning model, and you can make a prediction with this new data set. And you can also create an API to receive an input and make a prediction. And so you can make a machine learning model available via an API application where you can send and receive requests from the machine learning model by inputting the data and allowing the machine learning model to be built, and then receiving the output prediction from the machine learning model. And then it can be embedded. You can embed the machine learning model inside a web application. So this can be implemented via a web framework. And in Python, there's a few popular frameworks you can use, such as Django, Flask, and Dash. So you need to expose them to like an open API interface, which will enable the model to be consumed in various different applications, like I have here, such as websites, dashboards, spreadsheets, back-end apps, and line of business apps. So yeah, for production-ready API, so things like Flask isn't production-ready, and it states that when you use it, that more needs to be done to it. So there is a lot of things to consider when you have your open API, such as scaling your API, containerizing your API for your API environment, and documenting your API, retraining your model to avoid model drift, and also logging your API model. And usually the things that you need to nail down are your document structure. So it's pretty important to have a good document structure that will help prevent errors. And this can be helpful when creating a Docker container. And then preparing your files. So prep your files to deploy. And there are several different methods to do this, as I explained in the previous slide. And documentation. Make sure the document your endpoint so it can be used without any difficulties. And some services out there can create this for you. And then we have logging. So logging is what you should use instead of print statements when we're going into production. So it can be useful so you can track your API that it's working correctly. And you can see problems that through logging, you can see any problems that you may run into. And lastly, the way I have using Docker. So now that we have an API to deploy, you might want to containerize it. Docker, you can containerize your app through and have all its dependencies to make sure that it works in another environment. So next up, I have monitoring the model. So yes, now that you've developed an awesome predictive model that gives good results, deployed it and received good feedback, it's now time for monitoring and tracking. So like, it may sound obvious at this stage, but like, it's definitely crucial to monitor your machine learning performance after deployment. And it's really important to have a good strategy in place by identifying the right elements and for this process before reaching to production. So like, it may sound costly, but it's super essential to monitor and get maximum value out of your machine learning model. Like, think of it like you're going for a physical checkup or something. And model operating is an organizational task which allows you to check in on your model and that it's performing as expected. And yeah, so there could be two main tasks at this stage of the cycle. And the first one would be the system validation. So confirm that the deployed model and the pipeline meets the customer's needs or the project's needs. And then the project handoff. So when you're handing that's running in the system in production, the customer or user should validate that the system meets the business needs. So like in recent years, people really just paid attention to steps 1 to 4, like on the project lifecycle, and didn't really pay too much attention to what happened after the machine learning model was deployed. And it's super crucial to keep monitoring for errors and crashes. So if you don't monitor bad AI, so mistakes that people often make is they treat it like normal software when it's not. So once the model is built and it goes live, people sometimes assume that it will continue to work normally, and that's not the case. And it's important to keep monitoring the system and making sure it keeps doing what it's supposed to do. And if you don't, the models will degrade over time as you use them, which is known as the model drift. And this is also can be known as the model decay as well. So if a model is degraded, this concept drift means that the predictions offered in static machine learning models becomes less accurate and less useful. So glad I got a glass of water. So if you don't monitor, there will be unseen data. And a machine learning model is usually trained on a sample size of 10%. And this is typically due to the scarcity of labeled data, computational constraints of training a lot of data. So also there could be a lot of changes in the environment and relationships between variables. So a model is optimized based on variables and parameters at the time it was created. For example, if you imagine a spam detection model that was created 20 years ago and how this would compare to now, spam emails are hard to notice these days, and this is a good example of an environmental change. And then there's upstream data, which refers to operational data changes in the data pipeline. So it's super essential to monitor the machine learning that you're bringing into production because it's always changing. And trained data can suffer from bias, which can result in surprising outputs. And the example that I gave here in the slide is Amazon's recruiting tool. And this is an example. This is a big example I'm sure that many of you have probably heard about. But Amazon used an AI-based tool to review resumes and make recommendations during the recruitment stage. And the past decade of CVs submitted to Amazon were trained to prefer male applicants over women. And then basically the machine just did what it was trained to do, garbage in, garbage out. So it's super important for reasons like this here to monitor. Even what Richard said there in the keynote, he mentioned that there is a lot of unconscious bias in machine learning. So, and it's happening all over the world, and we need to be aware of this. And like I said, monitoring models can help prevent this. So there's a few different steps that's required to productionize a machine learning model. So the first one I have here is model flexibility. So your model should have the flexibility, but there is no perfect model out there. But there is a minimum set of real-life circumstances that your model should accommodate without any major redesigns. And it's important to note that you shouldn't use data that will not be available in production when you're prototyping. And it could be better to combine multiple models through stacking aggregation procedures instead of just stacking everything into a single model. And then secondly, the code quality. So from the beginning, just make sure that the quality of code is up to standards. When a lot of the work in machine learning model is exploratory and it could get messy. So you should be using version control, and notebooks don't scale unless you're doing pure exploration. And there's computational performance. So runtime can become second to accuracy when in the labs, but it's crucial in production, and this is especially for continuous intelligent applications. So many machine learning projects can fail because of poor runtime. So it's important to ensure that you have a balance between the model complexity and the accuracy. And this should be tested early enough in the project on limited data set before going full optimization. And then lastly here, I have connectivity. So facilitate the data flows and from your model, especially since the model deviations caused by broken data sources are harder to detect than outright application failures. So I have a good reference here at the end of the slides as well that goes into more detail. So automation in machine learning is super important. So this can allow businesses to adapt to changes that will be reliable, and this can help remove human error. So having automation will automate those time-consuming iterative tasks of the development process, and it allows data science and developers to build machine learning models with high scale efficiency and productivity. And it is essential to have code versioning and have this adapted to the process. And production code is separated from the concept of the iterative notebooks. And this is referenced by Tom Swan here at the bottom of the page. So I work in a team with him, and he created this nice diagram. So again, that will be at the end of slides as well if you want to read more into it. Yeah, so now I'm at the cloud services bit of my presentation. So there's a lot of different cloud services out there for machine learning, such as Google Cloud Platform, Microsoft Azure, and Amazon Web Services. But for this talk, and due to time constraints, I'm just going to specifically focus on Amazon Web Services and SageMaker. So yeah, so Amazon Web Services has 165 fully featured services, and the way I like to explain it is like Lego blocks in appearance, and services have functionality of their own. However, when you put them together in the right way with the right pieces, you can create something highly complex and amazing. And Amazon has solely provided their users with like a huge Lego toolbox where you can pick and choose which services you would like and how long for. So it's important to be aware of the different services out there, and when not to build a bespoke machine learning model. And there is loads of good machine learning services, such as one I'm going to name is AWS Comprehend. So it's for natural language processing. It can be possible to build a better machine learning model than these off-the-shelf services, but it creates a significant overhead to maintain. So at the end of the day, it's good to kind of evaluate it. How much does it need to be better to justify the overhead? So yeah, so I'm going to go into SageMaker now. So yeah, SageMaker is a great tool for data exploration and training and testing the data. So On SageMaker, SageMaker has a managed Jupyter notebook, and it comes with an extensive collection of popular machine learning algorithms that are optimized for the Amazon Web Services cloud. And then training in SageMaker is scalable, and it can distribute training across one or many instances. And you can do real-time predictions and batch transformations to deploy. And there's so many good benefits about SageMaker. Like, I absolutely love SageMaker. First benefit would be simplicity. So it uses many different services and provides an API that simplifies many tasks. For example, when you train and persist the model, you first need to run an EC2 instance, but before SageMaker, you would have to do this manually, whereas like SageMaker can handle all of this for you now, and you can make an API call using the AWS command line interface, the Python SDK, and SageMaker can launch these automatically. And it saves money as well, so it shuts down the training and batch inference instances when the job's complete, which means you only have to pay for one-time use. And then elastic interface, so you can enable elastic inference, which automatically scales the compute instance used for online inference. Monitoring as well, so yeah, SageMaker, you can monitor your it monitors your AWS resources and tracks metrics and logs outputs as well. So you can visualize these metrics to gain a quick understanding of how accurate your models are or how long model training takes. And their service is called CloudWatch for this. And then security. So SageMaker relies on an IAM user authentication for authentication and permission. And SageMaker, you can use S3 to store data, and it keeps it secure. And this is super important for securing data, especially when you have, like, for example, like the hospital data of patients, like that needs to be secure where no one else can see. And then we have collaboration. So a really good thing about SageMaker is that you can collaborate with people in your team and use the same notebooks. So for example, if I was off sick, like someone can come in and pick up the work that I've been doing because my notebook will be there on the cloud. And this is SageMaker architecture. So there's many AWS services bundled together that coordinates the creation and management of different machine learning services and artifacts. So I don't really have time to go through all the different services in SageMaker, but I have a reference in my slides at the end if you want to go and look at it. So yeah, so I have this in here because Chloe McAteer, who is in the Belfast team, her and myself went over to New York and delivered a SageMaker workshop by Connect NYC in December, and all of our materials are available at this link here, which I will actually post in at the end of this talk. And if you want to go through our SageMaker workshop and learn how to build, train, and deploy models, you can go there. And yeah. So yeah, to summarize, there are a few main takeaways that you can take away from my talk today. The first one would be, there is never a final machine learning model. And secondly, it's important for you and your team or your business to understand the machine learning process, as there's a huge gap of knowledge there. And every company or team is different, and there is different processes and ways of doing things. It just entirely depends on the problem. And after you deploy, monitoring is key to keep your product alive. And lastly, evaluate your problem and the way of doing things. Think of it like, is it the best way to solve it? Or can one of the off-the-shelf services on AWS, Google, or Azure help you? So yeah, here's a few of my recommended resources. So I have a course in Udemy for deployment of machine learning models, and then a SageMaker course in Udemy, and blogs, SageMaker architecture blog, like I mentioned, and the benefits of machine learning in the cloud, and the hands-on machine learning. And then also I have to mention the WWCode data science track. So yeah, so there's many resources here. So make sure to come and join our Slack group. and check it out in the Women Who Code website for upcoming events. And there is currently an awesome machine learning series run by a few of the data science leads, and I think we are on week 4 now. So, but you can catch up on all the previous workshops on the Women Who Code YouTube channel. So yeah, do make sure to check that out. And here's my references. That's me. So yeah, thank you everyone for listening. I had a great opportunity today to share my learnings and my knowledge with you, and I would love to hear from you and your thoughts and learn from you all too. So please reach out through my Twitter handle or my email, or even just send me a wee message and hop in. So thank you.